Hello and welcome to another session of my Data Preparation for Data Science webinar. My name is Gerhard and I'm a book author and data scientist at SAS. Today we are focusing on data assembly, and I would like to show you that data assembly is not only a technical thing, but also includes many of conceptual consideration, business focus, which you need to understand before you prepare and put your data for the analysis together. Let's take a look on a very simple analysis question. Maybe someone asks you, can you build a machine learning model for me that predicts the cancellation risks of your customer? From the first perspective, this sounds like a very classical task. We would like to get a predictive model, a classification model, and find out what are the good predictors to predict the risk. However, before you go and assemble the data, there might be many questions in terms of your customers. You need to ask from a business point of view, what is really meant with this question. So for example, you could ask, what do you mean by cancellation? Cancellation could mean, for example, do you mean the full cancellation of the product, meaning the customer sends the cancellation note or stops being a customer from a contractual perspective, or is it just a decline in usage? Maybe the customer doesn't need to officially cancel our services, but maybe he just goes down over time. So what is the definition of our target variable, of our label, which we would like to predict in our machine learning models? But also with the set of customers we are using. So maybe in our customer base, we have customers who have canceled their contract in order to use a more advanced product of our company. So they have canceled, but they are not bad customers like the lefters. They have canceled a certain product to use a more advanced product. How do we want to treat them? Should we use them in the analysis, or should we not use them in the analysis? And maybe there might also be other customers who have a terminated contract, but not because of they canceled, but we had to close their contract. Maybe they didn't pay the bill, or they did something fraudulent with their account. So you see that there are a couple of business questions which are relevant before you start analyzing, which you need to find out, for example, what records, what analysis subjects should I have in my analysis before I predict the model. And from a technical perspective, this maybe is just a simple where clause where you delete your records, but it's important to discuss this from a business perspective. Also the topic, what is the target variable? We already mentioned earlier that the cancellation of the product can be maybe something customer sending an email and saying, I'm not using this service anymore. However, this might also be a decline in usage. On the left-hand side, with the customer email, maybe this is just by taking directly data from a lookup table and joining it to our analysis data set where we have the list of customers who have canceled the contract. On the other side, when we do not have a hard fact whether someone canceled, we need to derive it from the customer behavior. We maybe need to define what is a non-usage or such a low usage of the product which we can consider that the customer has left us. In the second case, you need to maybe run analytical methods, or you need to define certain rules which derive this from a transactional data. So we see again lots of business focus being attached here, also the technical thing of bringing data together. Also, when we take a look on the same business question, say, yes, we can build such a model, but what is the business process, for example, for contacting customers? And are there any additional attributes and explanations that you need? So what does the business department need later on when they run the analysis? Is this, for example, just the risk score or the cancellation probability, or do we need to derive and provide additional variables for interpretation or decisioning, which also need to come along with the model? This is also something you need to define upfront before you start running your analysis. And another very important discussion is what is the latency period that should be considered between the end of data collection, of looking into the data, and the time window which is used to to collect the outcome events. Is this something which can be done immediately, or is there a latency window which needs to be observed because it takes quite some time to set up the campaign, to run the retention campaigns, to contact the customer? If this is the case in business perspective, you also need to make sure that your analysis treats the analysis data in the same way and doesn't use data, too recent data from a time perspective, which would not be available in operational mode when the model is used in production. This also needs to be observed, and this is a very important thing by observing the alignment on the time axis. Let's take a closer look into this example. And we see here different time windows with the different names in predictive modeling. So for example, the target window is the time interval where the target event is observed. The customer is buying a product, customer is canceling, a fraudulent transaction is happening. This is the target window. And another one is the observation window, where we see time intervals where this is the time interval where the input data is collected. And it's important for many analysis to be very careful whether these two windows are allowed to immediately follow each other, or should there be an offset window which needs to be observed to separate this data also from a timely perspective, that the model is not trained on data which is already too advanced from a time perspective, which would probably not be available when the model is run into production. This needs to be discussed also from a business perspective and has a very strong impact on the assembly of your training data for your supervised machine learning models. Let's take a little bit closer look on that. So an important consideration for the supervised machine learning models is that, for example, if a certain date, in my example here, the last day of June, is your database cutoff date, that you are only allowed to consider customers who are still active at this point in time. So customers who have left the company already earlier should not be considered here and should not be used. And it's also important not to use input data after this point in time to predict the outcome event. For example, in our case here, the cancellation event, yes or no, in the target window. To separate these time points is very important for a proper definition of your training data mart. And it is always a combination of technical things, of joining data, where clauses, derived variables, but also business considerations and making sure what is the proper allocation of records and observations to your analysis data mart or not. With this example, I wanted to highlight that as part of data preparation for data science, data assembly is a very important thing. But it is not only technical, but also has lots of business considerations. And data assembly is, of course, not the only topic here. I also speak in other webinar contributions on data quality for analytics or on feature generation. In general, I'm always using my presentations examples where I would like to combine that data preparation, data quality and analysis are highly interleaved with each other. And this is also the topic of my SAS Press books, which you see here. If you would like to see more content of my ideas, there are lots of articles and blogs on Medium and LinkedIn. I run regular webinars on YouTube, and I share my SAS code and my SAS tips and tricks on SAS communities and on GitHub. Thanks for watching. It's been a pleasure to present this topic to you, and I look forward to your comments and questions.